My name is Nitasha and my partners are Karina and Ellie. And we chose a problem for our theme 3. And theme 3 is basically just explaining a problem thoroughly and showing how we could approach it with different perspectives. So basically, we chose a problem off the Mr. Heron's level 1, level 2, level 3, and we chose a level 2 problem, which was interacting with cars. So our model later on, when we show you, will have Karina and Ellie coming at a distance at the same time. And then this is what our problem is. Karina is driving west towards Ellie's house at 30 miles per hour. Nitasha is driving south at 40 miles per hour. Both are headed for the intersection at 2 roads. And the rate of the cars approaching each other when Karina is 0.5 miles away from the intersection and Nitasha is 0.6 miles away from the intersection. So that is what we were given with. So if we go from there, you can tell that not only are we given some of the distances, but we're also given the d of x over d of t and the d of y over d of t. And I can explain to you how I got that. After reading out the problem to you, we drew a quick diagram. So here's the diagram really fast. Karina's going 0.5 miles per hour, and then Nitasha's going 0.6 miles per hour. We do not know this length, and we can usually use geometry to figure out this length, but this is what we are given, and this is what we know. So if we want to use Pythagorean theorem, which is a geometry concept, it's basically where you have one value, which is 0.5, and then you have the other value, which is 0.6. If you don't know the diagonal, which is technically c, so you'd be a squared plus b squared equals c squared, or you could say x squared plus y squared equals length squared, or whatever variable you want to use for the diagonal. So when you try to find Pythagorean theorem, you do x squared plus y squared equals l squared. So because we wanted the l squared to be our length. We know that x equals 0.5, so x squared would be 0.5 squared, and then y is 0.6, so we did 0.6 squared. And those together will equal length squared. So if you go more down, I showed my work. And we know that 0.5 squared plus 0.6 squared is 0.61. And then we have to get L squared by itself, so you have to do the square root on both sides. So the square root of L squared and the square root of 0.61, which gives us 0.78. So that would be our length right here. Length would equal 0.78. And that's Pythagorean. So after looking at the equation and then looking at Pythagorean theorem, we can try to see what our givens are in the equation. So in our equation, we know that Karina is driving west. So we know that she's driving west at 30 miles per hour. So that is our speed. So we did d of x over d of x over d of t equals negative 30. Because she's going left, it's not right, so that's why it's a negative 30. So then the same for Nitasha, she's going left and it's at negative 40, so that's our d of y over d of t. We already know from the Pythagorean theorem that our x and y is for Karina is 0.5 and the y for Nitasha is 0.6. So that's why we got Karina 0.5 and Nitasha 0.6, and that's our x and y. And then after that, we just solve for L, which is 0.78 from the Pythagorean theorem, so we got that. So if you look carefully, x equals 0.5, y equals 0.6, L equals 0.78, and we know our d of x over d of t is negative 30, our d of y over d of t is negative 40. But what we don't know is d of L over d of t, and that's what we'll be solving for. Hi, so now we're going to try to solve our problem with what we already know, which we saw from the givens, all the information we know. So first step is, what is the equation that we're going to use? And for this equation, we're going to use Pythagorean theorem, y squared plus x squared plus y squared equals length squared, because it's a triangle and we don't know what the side length is. So after we find the equation, we have to find the derivative, and by doing the derivative, we have to do the power rule. So x squared plus y squared equals L squared would become, if we did the derivative, 2x times d of x over d of t plus 2y times d of y over d of t, which equals 2L times d of L over d of t, which is right here. And after that, you're just going to look in, plug in your what you know. So we know that 2 is already 2. And then we know what x is, which is 0.5 for Karina. We know the d of x over d of t is negative 30. So that's one side of it. Then we know that for Nitasha, 2 can just be 2. Y equals 0.6. And then d of y over d of t is negative 40. So that's that side. This is all the right side. So if we go onto the left side, we do 2 times 2, which is regularly 2. And then L is 0.78, so we did 2 times 0.78. And we don't know what d of L over d of t. So when we look down, we get negative 30 plus negative 48 equals 1.56 d of L over d of t. So negative 30 plus negative 48, which is negative 78, equals 1.56 d of L over d of t. So if we want to isolate d of L over d of t, because that's what we're solving for, we have to divide 1.56 from this side and then the other side. So it would be negative 78 divided by 1.56, which ends up giving us negative 50 equals d of L over d of t. And the interesting...
In the clip you just watched, we can see 2 cars coming towards each other that represent Karina and Nitasha driving towards Ellie's house and meeting at an intersection. And one car represents Nitasha, which is 0.6 miles away from Ellie's house. And Nitasha is the adjacent side of the triangle, while Karina is driving at 0.5 miles away from Ellie's house, and she is the opposite side of the triangle. And in the background we can see bushes, which would represent our hypotenuse, which is 0.78. In the model we can also see how one car is going faster and the other is going slower, so that would represent Nitasha going at 0.6 and Karina going at 0.5. This just helps give a better understanding of the problem and the different speeds.
My name is Karina, and I did a different perspective than Nitasha. So my question was, Karina is driving west towards Ellie's house at 30 miles per hour. Nitasha is driving south at 40 miles per hour. Both are heading for the intersection of 2 roads. If both cars are approaching each other at a rate of negative 50 miles per hour, how many miles away is Karina if Nitasha is 0.6 miles away? So the first thing we have to do is figure out our givens. And we're trying to figure out x, and we know d of t is negative 30, y is 0.6, dy over dt equals negative 40, L equals 0.78, d of L over dt equals negative 50. So the first thing we have to do is figure out the equation we're using, which is the Pythagorean theorem. X squared plus y squared equals L squared. And then we have to figure out the derivative, which is 2x times dx over dt plus 2y times dy over dt, which equals 2L times dl over dt. After figuring out the derivative, we're going to start plugging in our givens. So 2 times x times negative 30, which is d of x over dt, plus 2 times 6, which is our y, times 0.6, times negative 40, which is our dy over dt, which equals 2 times L, which is 0.78, times negative 50, which is our dl over dt. After multiplying those out, we get negative 60x plus negative 48, which equals negative 78. And after that, we're trying to isolate x. So we're going to subtract 48 from both sides, and we get negative 60x times negative 30. And then we're going to divide negative 60 to both sides, which gives us x equals 0.5, which is how many miles Karina was away from the intersection.
Hi. So here's another perspective that we realized when we were working out the problem, that we actually kind of did it wrong. So what we thought was that our x was 30 and our y was 40, but then we realized that doesn't make sense, because why would they'd be going a distance of 30 and 40 when the distance is 0.5 miles and 0.6 miles. And we realized that's the speed of which they're going. And then halfway in, we realized, oh wow, we aren't supposed to have x equals 30 and y equals 40. So if we carried on through with x equals 30 and y equals 40, and then our d of t equal 0.5 and our d of y equals 0.6, we end up having the same thing, which was really interesting because when we did the Pythagorean theorem, we got y equals 50 and for this length right here, instead of y equals 0.78. And we know that because we know that y equals 50 for this one if we did it like this, because 40 times 40 squared is 1,600, and then 30 times 30 squared, add those two together, equals 2,500, and the square root of 2,500 is 50, which is interesting enough because our equation, when we solved it, we got that d of L over d of t equals negative 50. And it works out pretty interesting because, like, for this length, we got negative 0.78, but for when we solved it with the x equals 30 and y equals 40, we got the answer which is negative 0.78. So the whole thing kind of switches around, but in the end, you still get the same answers, but you just have to use the right variables. But it was pretty interesting because, like, we thought we were doing everything correct because, like, all the variables matched up. But then when you look at it specifically, you wouldn't be going 40 or 30, you'd be going miles. So thank you.
Hi, I'm Ellie, and today I'm going to talk about a different problem that how I approached it by using different clues. And this problem is a little bit different than Karina and Nitasha's. So here's my problem. Karina is driving west towards Ellie's house at 30 miles per hour, while Nitasha is driving north. Both are headed for the intersection of two roads. At what rate is Nitasha driving if she is 0.6 miles away and Karina is 0.5 miles away from the intersection? Given that the rate in which the distance of the two cars are away from each other is negative 50 miles per hour. Okay, so from the problem we have four givens. We have 30 miles per hour, 0.5 miles per miles, 0.6 miles, and negative 50 miles per hour. So what does this mean? This means that the distance that Karina is driving, so x would be 0.5, y is what Nitasha, how far away Nitasha is from my house, so that's 0.6 miles. And then we don't know what this length is, so it's not given, but that's why we use the Pythagorean theorem to find that out. But however, we know that the rate at which the rate at which the distance of the two cars are away from each other is negative 50. So we know that d of L over d of t is 50 miles per hour. So now we go over here to the Pythagorean theorem. So we have 0.5 squared plus 0.6 squared, and that's going to give us the length of the hypotenuse. So now after we have that, we have these given values. So we add that and find the square root, and that equals 0.78, which is the distance between both cars. Now we use the Pythagorean theorem and we take the derivative of this. So the power rule is basically, here's an example. So you multiply the exponent by the coefficient, and then you subtract the exponent by 1. So here we have 2 of x times d of x over d of t, and this symbolizes that you have taken the derivative. And then here again you have 2 plus 2 times y. So times y is the distance, and then again d of y over d of t to show that you've taken the derivative again. And then here is the same thing. So once we have this, it's easy because we have all the given variables. So all we do is just plug those in. So we have 2 times x, which is 0.5, and then d of x over d of t is 30, and then we have 2 times 0.6. And we're trying to find what d of y over d of t is, so that's unknown, so we don't know. And then here we have 2 times 0.78, which is L, the length that we have here. And then we're going to multiply that times the rate at which both cars are moving away from each other, and it's negative 50. However, if we had a different problem talking about a ladder and how the ladder was moving away from the wall, this would actually equal to 0 because the ladder itself is not changing, the distance it is. So that would be 0, but in this case it's negative 50. After we do that, all we do is multiply and add the variables, and we try to isolate d of y over d of t to find our final result. So once we have that, we subtract from both sides to negative 30, and we have 1.2 d of y over d of t equals negative 108, and we divide by 1.2 on each side, and at the end we get d of y over d of t equals negative 90. So what does this mean? This means that Nitasha is driving to Ellie's house at the rate of negative 90 miles per hour.